There are a couple of key points that are included and clickable and labeled anytime you graph a function. So let's throw down the function negative 3x squared minus 2x plus 5. Notice that there's a couple of these gray points over here. Those will represent your x-intercepts when available, y-intercept, and if applicable, your min or max. You can click on a point to make the label stay there. So over here we see the x-intercepts are still in gray. We can hover over them and see the points, or we can click on them to make the points stay. So whenever we are solving for intercepts, we can graph our functions and simply click on the intercepts to figure out where they are. Reminder, the y-intercept is on your y-axis. It's where x equals 0, and your x-intercept is where y equals 0. So let's check a couple of examples out. So when we are trying to solve for our y-intercepts, or x-intercepts for that matter, let's say we have something like this, x minus 1 times x plus 1 times x plus 2, which is not an x-intercept of the graph. So we can start by just plotting that function, x minus 1, and we have x plus 1, and we have x plus 2. So it says, what is not an x-intercept? Well, what we can do, we know we want our x-intercepts, so we can click on those three to make sure that we have them readily available. That's negative 2, negative 1, and 1. So negative 2, negative 1, and 1, those are all x-intercepts. But answer choice D, which is 2, 0, and here's 2, so not a point there. 2, 0 is not an x-intercept of this function. And again, something as simple as this, 5 to the x plus 3. Exponential functions are pretty tricky in the sense that we're so used to seeing y equals mx plus b that we're used to just assuming that the y-intercept is going to be the constant at the end. But notice over here, our y-intercept is actually 4. And that's because any exponent rule, right, if we have a 5 to the 0, and again, our x value is 0 at the y-intercept, is going to equal 1. So 5 to the 0 is 1, 1 plus 3 is 4. But that being said, yeah, instead of calculating it, you could just throw it into Desmos, graph it, and it'll automatically find the y-intercept for you. In this case, 0, 4. And even over here, which is or are x-intercepts of this graph. Again, that would be where y equals 0. You could set y equal to 0 and solve, but Desmos is going to make it very easy for us to just graph this function, and it'll display the x-intercepts for us. That's x plus 3 and x plus 2, and I'm going to put that all in parentheses so that it stays in the numerator, and then divided by, that's going to be x, divided by x. Cool, and then we can just zoom in over here, and so we can click on those points. That's negative 2 and negative 3 are our x-intercepts, so no negative 2 over here, but negative 3 is an x-intercept of this, so the answer is going to be A, 1 only.